Okay. So today we will discuss about synchronization of the alternator. So this is the synchronizing panel, so which is used to connect the alternator to the infinite bus bar. So if you look into the panel, so here we have a frequency meter, and this is a phase sequence indication meter, and this is the voltmeter, and these three are the sorry here we have three sets of the bulbs, and this button, if you press it, it will indicate the phase sequence, whether positive phase sequence or negative phase sequence. And this is the switch, VSS switch. So we can, by using this switch, so I can see the voltage across RY phase, or so YB phase or BR phase. And this is the synchronization switch, and here we have a switch which is indicating source 1 and source 2. So source 1 nothing but the voltage coming from the infinite bus bar. So these three terminals are nothing but the infinite bus bar terminals. So if I keep source 1, then so this voltmeter indicate the voltage across any two phases from the infinite bus bar. If I place this switch in source 2, the voltage from the alternator, that is source 2. So source 2 voltage is indicated when I keep this position in switch position in source 2. So I can observe the voltage here. So here we have, before synchronization we need to test whether voltage of the alternator is matched with the infinite bus bar. So by confirming that, we have so two bright lamp method, all dark lamp method, and all bright lamp method. So once we while conducting the experiment, so I will clearly explain so how these all switches functions. So here if you see, so here we are taking the three phase supply RYB phases. So let us suppose say this is an infinite bus bar. So I am connecting these RYB phases to the source one, so which will be treating as an infinite bus bar. And here it is a alternator. So this is a cascade coupled alternator. So this center one is the alternator. So this one is the alternator, and this mission, this is the DC compound mission. So from this mission, so we will get the mechanical input to the alternator, and this is the another small generator which is called as an exciter. From this exciter we will get the DC voltage. That voltage is given to the alternator field winding. So if we look into the terminals of the alternator, here we have so 1, 2, 3, 4, 5, 6. So these six terminals are the so winding alternator terminals, stator winding terminals. So R dash, Y dash, and B dash. So I will short three terminals. These three terminals I will short, and the output voltage from the alternator can be collected by using these three terminals R, Y, and B. So these three terminals are connected to the source 2. So nothing but the voltage coming from the alternator is given to the source 2, and the DC voltage. So here if you see, so I shorted these two terminals and I shorted these two terminals. So this is a small compound generator. So we will get the DC output voltage here. So I will give the DC output voltage from this exciter to this alternator through an ammeter and a rheostat. So this is the rheostat. So I am giving DC excitation to the alternator terminals, sorry, alternator field winding terminals FF is the field winding terminals of the alternator. So for this winding terminals, I will get the supply from this exciter. So now let me start the experiment. So here I am switching on the source 1. So I switched on the source 1. If I play this switch position in source 1, so if you look into the frequency meter, it is indicating 50 Hz. So supply frequency is 50 Hz, and if I press this red button, phase sequence will be indicated. So this is a positive phase sequence. Okay, and if I change this VSS switch, so if I want to measure the voltage between R and Y terminals, so here the voltage is around 430 volts. So 430 three phase volts, 430 volts is there. So same voltage is present between any two terminals. Okay. So now we will start the mission. So by giving DC supply. So now I given DC supply. So if I start the starter, so I have to move the handle to initial position to final position. So mission started running. So mission started running. So mechanical input to the alternator is supplied by this DC compound motor. Now we will look into the synchronizing panel. So I will change the switch position to the source 2, and I will see the RY phase voltage. Okay, I am placing this position in RY mode. So between the R and Y terminals. So now a small amount of voltage is generated. So now I am increasing the excitation, that is by decreasing the rheostat. Slowly the voltage starts increasing. Here if you see, so as I am giving the excitation, voltage increase. So if you see here frequency meter, so there is no any measurement here, because so the frequency is even less than 45 Hz. So here there is no indication. Now I will change the speed of the mission by changing the rheostat position. So I am increasing the, see here, from minimum to I am increasing the rheostat position. So now if we look into the frequency meter, so frequency, see here I am frequency getting increased. I will increase the frequency by seeing voltmeter reading also. See here voltage already reached 430 volts. Source voltage is, source 1 voltage is nearly 440, and source 2 also reached 440, but frequency here it is slightly less. Now I will adjust it. So by decreasing excitation, and I will increase speed to some extent. Okay. Now if you see the frequency is matched, so I need to adjust the excitation. So here frequency I got 50 Hz, and if you see here I got 430 volts from source 2. Source 1 is somewhat more, so I will increase excitation. I will increase excitation to some extent. Yes. So I will increase the excitation. Yes. So now the voltage is almost equal to the source 1. Yes, both. So source 1 voltage, that is infinite bus bar voltage, and source 2 voltage, that is alternator voltage, almost matched. So both voltages are matched. Now I will check the phase sequence. Source 2, that is alternator phase sequence, is clockwise, and supply phase sequence, so it is also clockwise. Phase sequence is matched, voltage matched, and frequency also matched. See here I am keeping in source 2, so frequency showing 50 Hz, and in source 1 also it is showing 50 Hz. Now, so as all the parameters are matched, now I will check by using two bright lamp method. Yes, see here. So simultaneously two bulbs are becoming bright and one bulb becoming dark. So there is a small flickering frequency is available. So frequency exactly it is not matched. So that's why this flickering is coming. If I place in all dark lamp method, see here there is small voltage difference. So that's why these bulbs are not fully dark. Now I will make these bulbs fully dark by changing the voltage. So I am checking now. So source 1 voltage is nearly 444. Source 2 is somewhat slightly less. So I will increase the speed of the mission to slight extent. Then the bulbs will become fully dark. So now exactly bulbs became dark and frequency 50 Hz, phase sequence is both supply phase sequence as well as alternator phase sequence are matched and voltage is also matched. Yes. So as the voltages, phase sequence and frequency all are matched, now I can synchronize the alternator with the infinite bus bar. Now I am closing the TPST switch. Yes. So I synchronized the now I synchronized the alternator. So with the infinite bus bar. So if the alternator is connected to the bus bar, suppose due to any by chance the mechanical input of the alternator, if the mechanical input of the alternator gets failed, now let us check what happens. Now I am closing the here. Now I am removing the mechanical input to the alternator. Once after alternator connected to the grid, so now I turned off the DC supply. That means the mechanical input to the alternator I completely so uh, I completely shut down. So I am not giving any mechanical input even though the mission is in running mode. Now the alternator is converted into synchronous mission, synchronous motor. So initially the alternator when it is connected to the infinite bus bar, due to some any reasons if the mechanical input failed, then the alternator becomes as a synchronous motor. So this is what about the synchronization of the alternator. So like this we need to match frequency, phase sequence and voltage of the alternator to the infinite bus bar. Fine.